Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 1st, 2025, just yesterday. It shows that the usual token-level reinforcement learning objective is only a good stand-in for the true sequence-level reward when training inference mismatch and policy staleness are kept tiny, which in turn explains why importance sampling, clipping, and routing replay make large language model reinforcement learning stable in huge mixture of expert systems. The paper is titled, Stabilizing Reinforcement Learning with LLMs, Formulation and Practices. And, as we will see later, the implications for large-scale model training are quite significant. Table 1 spells out how the two routing replay schemes bias the target policy during off-policy training. The full table compares R2 and R3 across the first mini-batch and the later mini-batches. In the first mini-batch, R2 leaves the target policy untouched because it keeps the natural routing, while R3 already changes it. In every later mini-batch, both R2 and R3 alter which experts handle each token, so the effective target policy becomes biased throughout training. Figure 1 shows that under on-policy training, the basic mini-RL with importance sampling stays the most stable and reaches the highest benchmark score. The top left panel tracks that benchmark score over gradient steps, where mini-RL climbs smoothly, while the version without training inference importance sampling collapses. The top right panel reports training inference KL divergence, which spikes badly when importance sampling is removed, but stays low and flat for the other variants. The bottom right entropy plot reveals that removing importance sampling also causes entropy to crash, so the policy becomes overconfident instead of exploring. The length normalized variants remain stable, but plateau at slightly worse performance, and adding R3 routing replay does not give clear gains in this on-policy regime. Figure 2 shows what happens once the training becomes mildly off-policy, with the global batch being twice the mini-batch size. The top left benchmark panel indicates that mini-RL with routing replay and clipping reaches the best and most stable scores, while removing clipping causes both baselines to collapse. The top right panel tracks training inference KL divergence, which stays lowest for the clipped routing replay variants. The bottom reward and entropy plots confirm that these stable runs keep improving reward without crashing exploration, so clipping plus routing replay effectively controls policy staleness in this regime. Figure 4 shows that under very strong off-policy training, the R3 routing replay with clipping is the only configuration that remains stable and keeps improving. The top left benchmark panel indicates that R2 without clipping collapses, while R3 holds the best final score. The top right training inference KL divergence panel shows that R3 grows slowest, so policy staleness stays more controlled. The lower reward and entropy panels confirm that only R3 avoids both reward collapse and extreme overconfidence. Figure 5 shows that, with a stable mini-RL plus R2 recipe, very different cold start initializations all end up with nearly the same benchmark score, so reinforcement learning training largely washes out pre-training quirks. The left panel tracks benchmark score versus gradient steps, and all three curves rise toward a shared performance band near the top. The right panel tracks response length, which fluctuates more noticeably, yet none of the runs shows runaway growth or collapse. Together, these trends suggest that once reinforcement learning is stabilized, total compute matters far more than the exact cold start data source. Alright, to wrap up, the key message is that token-level reinforcement learning only makes sense when training inference mismatch and policy staleness stay tiny, and that important sampling, clipping, and routing replay are the right knobs to control them. This gives a practical recipe for scaling stable reinforcement learning on giant mixture of experts models. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.